Hello viewers, welcome to my 15th math tutorial dated 17 June 2025. My name is Mr. Lovex Israel Orengo. Today's topic is matrices, Form 3, Part 2. In Part 1, I discussed about the order of a matrix and how to find the sum or the difference between matrices, that is sum, addition and subtraction. I also handled multiplying a matrix by Ascara. In this section, I'm going to handle matrix multiplication. Also, I'm going to briefly talk about identity matrix. This involves multiplying a matrix by matrix. Note that this is the most important concept in matrices. Without this skill, a student will deem mathematics to be a difficult topic. For two matrices, say A and B, A times B is possible only if the number of columns of A is equal to the number of rows of B. I would like to repeat. A and B are able to be multiplied if the number of columns of A is equal to the number of rows of B. The order of multiplication is row by column. That means elements in each row of matrix A are multiplied by the elements in each row of matrix B in a sequential manner, as demonstrated in example 1 below. Evaluate 2, 3 multiplied by 5, negative 4. This matrix is a 1 by 2 matrix. It has 2 columns. This matrix is a 2 by 1 matrix. It has 2 rows. Therefore, the number of columns in the first matrix is equal to the number of rows in the second matrix. And how do we multiply? This is the order we multiply, row by column. How do we multiply? The first term in the first row is multiplied by the first term in this column. And it is added to the second term in the first row times the second term in the column. That is 2 times 5 plus 3 times negative 4, which gives us negative 2. It has given us a term which is only 1, that's a matrix of 1 by 1. Note that 2 by 3, 2, 3 is a 1 by 2 matrix, while 5, negative 4 is a 2 by 1 matrix, and the product matrix is a 1 by 1 matrix. The product has a number of rows as the first matrix and number of columns as the second matrix. Therefore, we are saying that when you multiply a matrix by a matrix, the product matrix has number of rows equal to the first matrix and has number of columns equal to the second matrix. For example, this matrix, the product matrix has 1 row as the first matrix and it has 1 column as the second matrix. Question B. Evaluate 201 times 4, negative 2, 3. Row by column means 2 times 4 plus 0 times negative 2 plus 1 times 3, which gives us 11. C. Evaluate, this one is a 2 by 2 matrix times a 2 by 2 matrix. In this case, we are going to multiply row by column. Row 1, column 1, we get 1 value. Then row 1, column 2, we get the second value. Row 2, column 1, and finally row 2, column 2. Now for row 1, column 1, 2 times negative 2 gives us negative 4 plus 1 times 6, which gives us 2. Then row 1, column 2, 2 times 2 plus 1 times negative 9, which gives us negative 5. Row 2, column 1, 4 times negative 2 plus 5 times 6 gives us 22. Row 2, column 2, 4 times 2 plus 5 times negative 9 gives us negative 37. Question D. Evaluate this one by this one. This has 2 rows, 3 columns. This has 3 rows, 2 columns. We multiply row 1, column 1, row 1, column 2. Then row 2, column 1, row 2, column 2. Now for the row 1, column 1, 2 times 6 plus 5 times negative 1 plus 4 times 3, which gives us 19. Row 1, column 2, 2 times 0 plus 5 times 5 plus 4 times negative 2, which gives us 17. Row 2, column 1, negative 8 times 6 plus negative 3 times negative 1 plus 2 times 3, which gives us negative 39. Row 2, column 2, negative 8 times 0 plus negative 3 times 5 plus 2 times negative 2, which gives us negative 19. Example D, example E, evaluate this by this. In this case, we have a 2 by 2 matrix multiplied by a 2 by 1 matrix. Now, negative 2 times 5 gives us negative 10 plus 3 times 1, which gives us negative 7. Then 6 times 5, 30 plus 4 times 1 gives us 34. Now, that is all about multiplication of matrices. Identity matrix. This is a square matrix in which each element in the main diagonal is 1 and the rest of the elements are zeros. A square matrix of 2 by 2 is given as 1, 0, 0, 1. A square matrix of 3 by 3 is given as 1, 0, 0, 0, 1, 0, 0, 0, 1. The main diagonal is the one which starts from top left to bottom right, as indicated. When a matrix A is multiplied by an identity matrix, the result is A. It means an identity matrix does not change or alter any term of a given matrix. It is like multiplying a number by 1. 2 times 1 you get 2. 1 times 2 you get 2. 1 times 10 you get 10. Therefore, an identity matrix behaves as a numerical number 1. Now, consider this. This is an identity matrix multiplied by this one. 1 times 2, 2 plus 0 times negative 6, that is 0, get 2. 1 times negative 5 plus 0 times 7, negative 5. Row 2, 0 times 2 is 2 times 1 plus 1 times negative 6, negative 6. 0 times negative 5, 0 plus 1 times 7, we get 7. You see that this product matrix is the same as this matrix. Example 2, solve for the unknowns in the equation below. We have 8, 3, 5, 2, x, w, x, y, z equals to identity matrix. What do? We multiply, then we equate to the identity matrix. Now, 8w plus 3y this here, 8x plus 3z this here, 5w plus 2y this one, 5x plus 2z this one equals to 1, 0, 0, 1. Here we are going to consider equations and solve them simultaneously. For example, let's consider two equations in w and y. These two, the first two. 8w plus 3y equals to 1. That's equation 1. 5w plus 2y equals to 0. When you solve them here simultaneously by elimination method, I want to eliminate y. I multiply the lower equation by 3 and the upper equation by 2, so that I can have 6y, 6y at this case. Now this one gives me 16w plus 6y equals to 2. That's 15w plus 6y equals to 0. Now that the two are the same, we subtract. 16w minus 15w gives us w. 2 minus 0 gives us 2. Therefore, w equals to 2. If w equals to 2, we'll consider one of the equations. I will consider the second equation. 5 times 2 plus 2y equals to 0. 2y equals to negative 10. Y equals to negative 5. We also consider the two equations in x and z for us to find their value. Now, we have considered this one. 8x plus 3z equals to 0. Then 5x plus 2z equals to 1. I multiply the first equation by 2, the second equation by 3, so that I can eliminate z. Now this one gives me 16x plus 6z equals to 0, 15x plus 6z equals to 3. I subtract 16x minus 15x, we get x, 0 minus 3, we get negative 3. Therefore, 5 into negative 3 plus 2z gives us 1. 2z equals to 16. Therefore, z equals to 8. Therefore, in this case, w is 2, y is -5, x is -3, and z is 8. Thank you for watching. Welcome in advance in our next session.